Okay, so this one you should be able to do on your own. Consider this matrix. Find the inverse. Okay, so we got lots of answers in. We'll give you another 30 seconds. Okay, last call. Okay, last call. Yes, people still had a break. Numbers are down. Okay, so the correct answer, which most people got, was E. Matrix isn't square. Only square matrices have inverses. What could you have done with this matrix? Could have done it pseudo-inverse. Right. Is any of these the pseudo-inverse? A is definitely not the pseudo-inverse. So the pseudo-inverse is a lot more complicated. You have to do like SVD, take 1 over the items inside of it, and you don't get something as simple as taking 1 over each of the items in the matrix. That just doesn't get you there. Oops, wrong thing. Oh well. Let me close that one off because that's not the question. Okay, so consider this system. Apply Kramer's rule to to solve this. What is U? Actually, there's enough matrices you can split the determinants up among your team, so go ahead and work in pairs. Okay, we'll give you another 30 seconds. Last call. Okay, so most people got the correct answer was C. So if I want to do Kramer's rule, I need 4 different determinants. So first the determinant of A. I'm not going to go through all the math, but that's 6. The 3 A1, A2, A3s, where I just replace the right-hand side towards the first column, the second column, and third column. Give me 6, 6, and 12, and then I take the ratio. 6 divided by 6 is 1, 12 divided by 6 is 2, 18 is 3, and I get the answer was C. How many people solved it not using Kramer's rule, but did something like Gaussian elimination or whatever? Okay. So just to let you know, on an exam, if I ask you for Kramer's rule, because that was explicit, I'd probably want to see Kramer's rule. You'd get some points for doing Gaussian elimination, but if I'm testing, do you know Kramer's rule, then I would want to see that answer. It's a good idea if you know how to do more than one technique. You can always check your answer by doing it both ways. Here's Kramer's rule, but I'm more comfortable with Gaussian. I did it as Gaussian. Okay. So, given the following data, if I do a linear regression, or least squares linear regression to the form y equals a0 plus a1x, what value of a, the value of a is most closely one of these 5 values? So what's the slope if I do least squares fitting to this set of data? You can work with a partner. Be another 30 seconds. People still working? Maybe a little more then. Okay, last call. Okay, so we get a lot of spread on this one. The answer is 42, but that's to a question I don't know what it is. The correct answer for this one is actually C, 32.65. Okay, so again, we can do this by forming the normal matrix, right? So 1, 20, 30, 40, 1, 1, 1, 1 times A1, A0 equals 1, 4. That's our equation. For each point, we're saying A times, this value times A1 plus this value times A0 equals that. So that's our equation. We multiply that, we take the transpose, multiply it if we want to do the normal equation. That gives us this matrix, which we can then go ahead and solve. Right? And you solve that, you get 32.65. So did people who have, because there were a lot of people with like the answer B, how did you get B? Was B just a guess? There were 13 B's. It seems unlikely everyone just randomly guessed B. No one wants to own up to a B? Okay. So just in case you wanted to, like, if you were doing this in Python, so this is related to your programming assignment because you have to do stuff with solve. This is a linear model. We'll actually do quadratic in just a second. If I was to do this in Python, the triple arrow here is the Python prompt. I just type some of this in, right? So I just define the matrix. Then I define A as NP dot of V transpose and V, right? So that just gives me the two matrices. So that gives me the product here. And B is V transpose dot W. So that just gives me this matrix written out. And I might have put these, this one I think I might have put them in a slightly different order. And then when I solve it, I get the 32 and the minus 116 order. So. Sigma sometimes represented by W. Yeah, some people will write SVD as with a sigma. Others, use sigma V. Others will put a W in there because, like in normal typing, sigma's hard to get to. W's a lot easier, right? You already got U and V. Why not include W? Right? They're neighbors. So if I wanted to do a quadratic fit, how would I do this? If instead I had that same data, but I wanted to build a quadratic model, what would I do? What would my matrix look like? I have another column, and what would be in that column? Well, it would just be the squares. So it would be 1 squared, 20 squared, 30 squared, 40 squared. So now I have this matrix, and I solve that in a least square sense for A2, A1, A0. And again, I can do that by building that matrix, doing the multiplication, and then so in Python, I can just use linear algebra solver to get the answer, and I get a very different set of answers. Now, with respect to your programming assignment, it's fine with me if you want to use the normal equation formula, and then have a 2 by 2, a 3 by 3, and a 4 by 4, which you could actually solve. Or you could also solve this in every language you're going to find. There's an SVD or something that will let you solve in least square sense. So Python has a least squares solver, which you just give it V and W, and it gives you back the least square solution, which actually is based on SVD. In fact, it gives you down here the singular values of what goes on in your solution. So any one of those would be a fine way of trying to computationally solve it.
I'm having a
Here? Oh, because I have to multiply both sides by A transpose. Okay. Right. If I do something to the left-hand side of the equation, I do the same thing to the right-hand side of the equation. So if I multiply by A transpose, multiply by A transpose. And hopefully that's like the right multiplication comes out of what I did there, so it should be, yeah. Okay, so if you graph all 2D vectors of a unit length with respect to the Euclidean norm, the outline forms a set of circles. What is the form of the outline for the Manhattan norm? This is on your own, and it should be pretty quick. Either you know it or you don't. The Manhattan norm is also called L1 norm. Someone's going for 42. Oh, okay. Well, talked another person into it. Going for the humor. Okay, last call. It's gotten a little better. Final call. Okay, so when we think about what norms are, right? So the Manhattan norm is what happens when I take the x component or the y component, right? So it's like how much did I go in x plus how much I went in y. So equidistant in that norm is a diamond, right? Just because I go over and up or up and over, it gives me the same distance. And so this is a unit circle under the Manhattan norm. It's not quite a circle, but it sometimes gets called a unit circle under that norm. So notice that all of the following vectors, 0, 0, 1, 0, 0, 1, 0.5, 0.5, all of these add up in absolute value to 1. And so they're all on this unit distance. Okay, we'll do one more of these. Given the 5 points, P1 through P5 here, find the least squares approximation using a straight line. I really want to make sure you know how to do this one. Drive your programming assignment. Don't think it matters. It's a list of points. Their names don't matter. But that's the kind of thing dyslexics like to do. We like to rearrange things just for fun. People still computing? That gave no information. It was just for fun. Yes. Okay, I'll go for last call here. Probably shouldn't have done that, but okay. So we've already done a couple of these. The ways we solve that, we form this matrix, right? In this case, 1, 0, minus 3, 3, 0, right? Where I've just taken the x coordinates, the top coordinates. The y's go on the right-hand side. Multiply this by A transpose. It gives us minus, 19, 1, 5, 4, whatever. Now you solve that and you get minus 2.2. So the correct answer is not D, which is what I typed, because I forgot the minus sign. So the correct answer was E, which, yeah. So you're stuck going down from, oops, back up. Stuck going from this,
From that to the x to.
Okay, so do you know how to solve a 2 by 2 system of equations? There's like a formula for that one?
I possibly have forgotten.
Okay, anyone want to throw him a lifeline for a 2 by 2 matrix? I mean, first of all, you can just do Gaussian elimination. Right? 2 by 2, right? So we're all, you can solve 19, 1 with the Gaussian elimination. So not a bad practice. But there actually is a formula for 2 by 2. And you remember it? So we have A, B, C, D is our 2 by 2 matrix, right? We get 1 over AD minus BC times DA minus CD or something like that. Is that correct? I have no idea.
The C and B stay in the same place.
Oh yeah, the signs are correct. C, C and B, and I put a minus on it. Something like that. There's a formula for it. I don't use the formula, so I don't remember it. So don't believe this formula.
It's Gauss. It's Gauss elimination all the way.
I would just do Gaussian elimination. I find one thing that works for me and just keep doing it. I don't need to have special formulas that there's like 8 letters in there. My chance of getting a minus sign wrong is just way too high.
How would you get from the first
Here to here. So I multiply by the transpose of this. That's what we mean by A transpose.
We multiply all 3 elements that are transposed?
No, so I multiply, so I have 1, 0, minus 3, 3, 0, 1, 1, 1, 1, 1. And I multiply by that, so I have 1, 0, minus 3, 3, 0, and 1, 1, 1, 1, 1. Down this, I get 19. Down this, I get 1. 1, 0, minus 3, 3, oh, they cancel out. So yes, I get 1. This one I get 1, and this one I get 5. And I do the same thing to the right-hand side, which is what I get minus 4, 1, because I do that times take that times 1, 0, 0, minus 1, 1. I go across that, I get minus 4. So, okay? So this is called the normal form of trying to solve least squares problems. For your programming assignment, you can do this, or you can just form the matrices and call libraries. I'm okay either way. The most important thing is you get really comfortable with how to form that matrix, because you have to form that matrix. If you don't get this right, nothing else will make sense, right? So if we wanted to fit quadratics in this data, what would our matrix look like? Just square this column, 1, 0, 9, 9, 0. I have a 3, but if I wanted to do a cubic, 1, 0, negative 27, 27, 0. So building the matrix should be pretty straightforward, and then you just do the fitting. Quick engagement question. Okay, last call on engagement. Okay, so before I get to the next clicker question, just to give you a little background, this class has grown larger and larger. They're now talking about trying to offer it a little bit more often because it's already big and CS enrollments are still growing. So one of the things I have been tasked with is to try and figure out, could I do this course online? I asked this question last year, but I figured I'd ask it again this year to see what people, I didn't ask the question quite the right way last year. It was binary, do you think it should be online? So I'm now asking as a clicker question, which is now open, your view about if this class were offered online. Right? It's already flipped, I've got all the videos, so all that content is there, but the in-class part wouldn't be the same. I could actually take the sort of online clicker questions, literally like the videos I have now. I could present a question, you get to work on it, then you get some feedback, and so I could, with a bit of effort, make that part online. So what do people think about if this class were offered online? Would you be interested in it? You think you'd take it? You definitely wouldn't? Again, this is just feedback so we can talk about how we would do stuff moving forward. Working by yourself, clicker points probably wouldn't count much because it'd be too easy for you to just be looking stuff up on the side. So there would be more of a shift towards the programming and exams for grading if it was online, if that matters. Okay, last call on that. Okay, so I'm going to actually ask a related question because that's a little more skewed from last year. So one more clicker question related to that. What do you think about online courses in general? Because I'm trying to figure out, is it the issue that people who take in-class classes don't like online classes? In which case, I'm surveying the wrong people because you're all in an in-class class. Okay, so okay, last call. Okay, so that's actually all I had planned for today. But before we leave, right? So I'll stick around. I'll answer questions about the programming assignment if you have some. Next week we're gonna have so I left some time, but not quite this much time anyhow, because I thought we'd be doing FCQs in class today because in the original schedule this is the time of the year we should be doing FCQs. FCQs have moved to be online this year. They will be available December 1st through the 8th. I will post a link in Blackboard so you can do them at your leisure or whatever. I will leave a little bit of time next class for it, but because it requires you have your computer, not everyone will sort of be able to do them in class anyhow. So next class we'll be doing two things. So there's a video that's the material not in the book about floating point and round off. This actually is very important information. So for next week, there will be clicker questions. You need to watch the video on that stuff. The book talks a little bit about condition numbers and round off error, but doesn't have the level of detail of the video that's on YouTube. And then we'll have a little bit of review for the final. So again, I will try and post by Saturday or Sunday your grade, including today's clickers and program 5, so you have a pretty good feel for where you are. The name of the videos will probably be something like, it's actually...
Saturday being posting, like as an assumption if we don't do program 6. Is that correct?
Sorry, say again?
The Saturday grade will be as if program 6 is 0 out of 4 or upgraded.
Yeah, so what I'll post is assume you get a 0 on program 6, that will be your standing in for assuming that. Go to prediction. So it's called numerical issues in chapter 30. So you can only go higher. You can only go up after that. So they give you a lower bound. If you're safe with the lower bound, you're safe. Work hard for program 6.
I'm happy with it. I want to see what that lower bound is.
I was told floating point average was going to be today. What happened? I was promised floating point rounding error.
So I prepared for floating point rounding error, and then I noticed that the syllabus had that for next week. And I looked at like the views on the video, and no one's watching it. Like 2 people have watched it since last year. It's like, okay, no one watched those videos because the syllabus said that was next week.
Right.
I've actually my online syllabus and my syllabus are different. I changed stuff and I forgot to update the online. So
I'll send you an email. I'm going to go to the library and send you an email about how to run. So.